Zeroed in on me. Episode 2 of Everybody's Podcast. It's been an interesting week, an interesting 5 days since we put up our first episode and started posting clips, or at least Opus Clips started posting clips for us. 11 subscribers. Let's see. 13 people viewed the episode, but not very many finished it. But that's what you'd expect from YouTube. How are you feeling?
I'm feeling pretty good, dude. How many views overall did we get off those shorts?
We are at, well, as of yesterday, as of last night when YouTube counted, 5,300 views and 40 hours watch time.
That's awesome.
It's impact, yeah. We've also gotten every single podcast, what's the word I'm looking
for?
Platform, yeah. So we're on iTunes, Spotify, YouTube Music, all the major platforms now. And it didn't take them too long to approve us.
Less than 24 hours on all of them, right?
Oh, yeah. Actually, iTunes approved us in 3 hours. So
that's wonderful.
Do you want to look at some comments?
Sure. Our
first comment, it was talking about dark matter. And the first comment from Scott83083, more black holes than we think. What do you think?
I don't have any comment on that.
It's entirely possible, Scott. One hypothesized source of dark matter is primordial black holes. Primordial black holes would have formed as part of the Big Bang and immediately after. And they wouldn't have to be the size of regular black holes. Normally a black hole, or at least the most accepted model of how a black hole forms, would be that a star, when a star reaches the end of its life, when it collapses, if it's heavy enough, if it's big enough material will be left over for it to exceed about 3.5 solar masses. And at that point, it will collapse into a black hole. But when a star collapses, so much material bounces back out that, from what I've read, you usually need somewhere around 8 solar masses, so 8 times the size of the sun, for it to actually collapse into a black hole.
Okay, but how big do these primordial black holes got to be?
So they don't have to be very big at all, at least as they're hypothesized. There's a minimum size that a black hole has to be. I'm not sure what that mass number is. There's a point at which it gets so small that the Hawking radiation is enough for it to just blow apart at once, like in a flash. We can look up what that is if you want to.
Yeah, sure.
Okay, let's see what Gemini tells us. Minimum size of a black hole. All right, it's thinking. Okay, so let's see. So what it says is the theoretical minimum, the absolute theoretical minimum mass for any black hole is conjectured to be the Planck mass, approximately 2.176 times 10 to the negative 8th kilograms. Yeah, I don't know if
I believe that.
Yeah. That would be so incredibly small. Anyway, I guess there's a lot of conjecture, but the point is there could actually be a lot of primordial black holes like that, like 10 to the 60th, 10 to the 70th, a whole lot of them. And black holes are very, very long-lived. So the equivalent is if you were to take the amount of time the sun will live versus the amount of time a black hole exists as a black hole, if it wasn't taking any more matter. Black holes keep sucking in matter. But if they stop, there's some radiation that comes off of those. It's Hawking radiation. And what that is, if you take the vacuum energy of space, you can have particles and identical but opposite antiparticles that burst into existence at the same moment. But then in empty space, they would then collide back into each other and collapse back to zero very quickly. But if you're on the event horizon of a black hole, if you're right on the event horizon, so On one side of that point, everything is trapped within, and on the other side of it, things can escape. If you were to have a particle and antiparticle form right at that border of the event horizon, and one were to escape and the other were to fall in, you would get this little bit of radiation.
So the antiparticle falling in?
Or the particle falling in. Doesn't matter. Either way, it's going to have the same mass, the same energy. So that's what's called Hawking radiation, and it's a small amount of energy that is constantly exiting from the event horizon of a black hole. And over time, that will allow the black hole to evaporate, to burn off.
Okay.
So a black hole, a regular minimally sized solar-sized black hole, star-sized black hole, you would expect it to live about 10 to the 65th years before it vanished. And the equivalent is, if the amount of time our sun would live was about 5 inches, about the length of a popsicle stick, then the length of time a black hole would live would be from one end of the visible universe to the other.
Ah, okay.
So anyway, Scott, it's entirely possible that it's more black holes than anybody ever expected. Next reply from MATG, Matt G, 3802. What a dumb clip.
Yeah, well.
We do what we can. Let's see, we've got some more comments. Let's see what else people have to say. Ben and Sylvia. Now this was the clip explaining Vera Rubin and how she discovered dark matter, how she discovered the galaxies were spinning too fast for the amount of visible mass they have. And he said, that's a very good way of explaining how we know that dark matter exists. Great job. Thank you, Ben and Sylvia. I really appreciate even the negative feedback, because negative feedback gives you an idea of what you should improve on. But positive feedback feeds my ego, so thank you. That might be the last of our comments. We don't have any more comments than that. Oh no, we got one other. Let's see. This is from Cosmic Rivers, unveiling dark matter with quasars. So talking about how quasars, they crank up and it goes through all those
And the light bends.
Is this a premonition from the 1990s?
I think he's commenting on our video quality. I think it was low light.
I don't know. I think he was saying our style is bodacious.
No, I'll take it.
I don't know if it's a premonition, but here we are coming straight at you from the 1990s. So a few days ago, I asked you, what does the phrase becoming who we are, does that mean anything to you?
Oh, you asked me, how do you become who you are? How are you always becoming who you are if you are already who you are? I don't have any special thoughts on that. I haven't thought about it.
It's a phrase that Nietzsche uses, Friedrich Nietzsche, that he uses throughout The Gay Science and actually a few of his other books. He uses the phrase, we have to become who we are. It shows up first, I said, in The Gay Science. So aphorism 270 of book 3, what does your conscience say? You shall become who you are. And in context, starting with aphorism 268, what makes one heroic? To face simultaneously one's greatest suffering and one's highest hope. And what do you believe? In this, that the weights of all things must be determined anew. What does your conscience say? That you shall become who you are. Where are your greatest dangers? In pity. What do you love in others? My hopes. What do you think?
It's an interesting thought, dude. Far deeper than I was anticipating on getting. I don't have any thoughts right off the dome for that.
Okay. So, I get the impression that with the way Nietzsche describes becoming who you are, you shall become who you are. It implies that in my mind, it implies that who you show yourself to be is different from who you actually are. And who you show yourself to be is how you act in the world, or the face you put on for the world.
Okay.
It's a dissimulation of yourself, right? It's almost, we know when we go to work, we got to put on the costume and wear the company's
Right.
costume, right?
You have to wear the clown suit to the circus.
Right. So I don't normally watch TV, but whenever I got to fly, I watch the seat back TV. Gives me something to look forward to. But I've been watching Yosemite, which is kind of
It's a fun show.
it's so dramatic and in a lot of ways impossible. I mean, how could a rancher possibly afford to chase cattle with a helicopter?
Daddy's money.
I mean, that helicopter burns off what, $300 an hour?
Yeah, dude. An hour of flight.
Yeah. You gotta.
I don't know what kind of maintenance is required on a helo for 1 hour of flight, but I know with aircraft it's over 20 hours of maintenance hours per hour of flight.
Oh, are you serious?
Yes.
Do you know if that's also true for commercial aircraft?
Civilian and commercial. I imagine that privately owned, like Cessna and stuff like that, it's probably less because the person maintaining it is going to be the pilot. But I know commercially and military-wise, fixed-wing aircraft, it's 20 plus hours of maintenance hours.
Oh, are you kidding me?
Yeah, for 1 hour of flight time. And that's because it's what you call a super safe environment.
Sure.
The whole idea is to minimize risk to the tens of millions, like
Okay.
catastrophic events to the tens of millions, where they want the craziest thing that happens on a commercial flight that any one person sees in their whole lifetime might be that a panel gets ripped off in flight.
Okay.
That's scary. No one wants to see that on an aircraft that they're flying on. But if you fly all of your life and that is the worst thing you ever see,
You're winning.
yeah, that's what
Okay.
the system is designed to look like. And of course, there's
So make that panel flying off like a 3 or 4 sigma event.
yeah,
Okay.
and obviously there's cases where these aircraft go down, and a lot of the time it's just things that you can't control that happens, but some of the time it's just bad maintenance or a bad culture around maintenance. When someone forces an aircraft to fly when they haven't completed all the maintenance, or they've built a culture around shotgunning maintenance
Okay.
or rushing through it, not being exact with it. So aircraft flying is supposed to be a super safe environment, and for the grand majority of the time those standards are followed.
So in comparison to, for example, paying, because what I was thinking in terms of was paying the pilot, paying for the fuel.
Those are expensive.
So how do those compare in cost versus the maintenance?
Well, I don't know how much any one of those things costs. I know jet fuel ain't that cheap.
Oh, that's true.
I don't know. I believe helicopters, well, at least military helicopters run off of essentially diesel, JP5, which is jet fuel.
Well, military helicopters, they have turbines.
They have straight up jet engines.
So the helicopter in Yosemite, it doesn't look to me like it has a
Yeah, it probably has a regular gasoline engine or something
Oh, so like an internal combustion engine.
that spins the rotors. But I don't
Right.
know. I don't know anything about helicopters, dude.
The other thing is they are all living like super dramatic lives. And to be honest, most people I know who, I mean, I guess I don't really closely know anybody in that ranching business, but most of the people I know who are operating a business,
They spend a lot of time not ranching for what is required to run a ranch. I forget the guy's name, but they essentially have slave labor out of that one guy. That basically is number two in command.
He kind of is number two in command.
He is absolutely number two for all the hired hands.
And he pretty much does what Kevin Costner's character, whatever Kevin Costner's character wants, and whatever he believes.
Have you learned the context of that relationship?
The ranch hand guy, he had to off whatever his mom's boyfriend. His mom's boyfriend murdered his brother and was beating the tarnation out of his mom.
Yeah, so he beat him to death.
That's right, with the iron skillet.
Yeah, and in order to not face time, they basically hit him on that ranch.
Okay.
I think that's what it is. It's been a long time since I watched the show.
The thing is, even if that had gone to trial, he would have had just...
Yeah. And him being a minor.
Right. But anyway, he just became Kevin Costner's, I don't know what to say, his bulldog.
I think of him as his slave, dude.
Yeah, but the thing
He's
is...
incredibly loyal, though.
And he acts with autonomy to try to do what he thinks is right for, not necessarily right, but to do what he thinks will preserve Kevin Costner and the ranch as a business. I haven't even gotten all the way through season 1.
Okay, all right.
No, wait, I have gotten through, I'm somewhere in season 2. So I don't know, they're portraying him as caring about human life, as being someone who actually cares about others. The wildlife investigator who was digging into what he was doing, when she landed on that pole, he did everything possible to save her life and succeeded. Do you know what part I'm talking about?
No.
She got thrown from a horse. They were riding horses together, and he said, "Hey, there's a horse fly on your horse," and she's like, "Yeah, you ain't coming near me." And then the horse fly bit her horse, and her horse bolted and threw her off, and she landed on a fence post, so it impaled her all the way through her abdomen. But she didn't die. He managed to pull her out and got the helicopter to actually come, and they took her off to the hospital. But then you get this feeling, oh, he cares about her life. But then also he said, listen, you can't die, because if you die, nobody's going to believe that I didn't do this. So there's this element of self-preservation there too. So you're not really sure what's his real motivation.
Well, to be honest with you, what evidence is there that she even made it to him?
What do you mean?
I think it would be just as well for him, if he didn't care about human life, is that she dies and then he goes and finds, he found her later.
Okay. But he didn't think anybody would believe that.
That's enough. I think that's enough doubt.
Okay.
But if he gets found out, because his whole existence is kind of illegal in that whole scenario.
What do you mean?
They don't know where this 14-year-old boy went.
Right. He just disappeared.
Yeah.
Okay. So the deal is that he has this hidden identity.
He has to keep anonymous.
Okay. So his variability to live is tied to the survival of the ranch.
Yes.
Okay. Well, it's pretty tough when somebody's survival is tied to something. It's pretty much impossible to disentangle them from it.
Yeah.
And that's kind of how people get stuck into religious cults that they grew up in, because this belief system has been, basically from when they were children, has been made their source of human contact, of human acceptance. And so they know that if they leave, that acceptance is gone, and they don't know where new acceptance will come from. And we can stand outside of it and say, hey, there's a whole world full of people who would welcome you. Maybe not a huge percentage of the world, but you don't need a huge percentage. even 1/100%, 1 in 10,000 people it's still going to be tens of millions of people who'd be happy to have you around. And you don't even need tens of millions. You only need 10. 10
Yeah.
would be a win. So if his belief that he can survive only if the ranch survives, then he'll do anything.
It's true. Yeah.
Okay.
But I mean, the idea that you'll do anything, but you still have control within that.
Okay.
You get what I mean? There's more than one way for him to reach some logical conclusion that this protects the ranch.
Okay, sure.
Letting her die versus letting her live, or doing what he can to have her survive.
Uh-huh.
He could bring either of those to a logical conclusion where the ranch survives. And either one of those, you could also argue that puts the ranch in jeopardy.
Okay.
Because what the viewer is supposed to believe is that this woman is jeopardizing the ranch.
Sure.
So that the whole point of that scene, it seems to me, is to show his humanity.
Okay. So what you're saying is he could have let her go either way without really much consequence to himself.
Yeah,
But-
I mean, throughout the show, they know how to. There's this idea that they know how to hide the bodies.
Sure.
So, and the other part of that is the ranch has some sort of plot armor until it reaches its conclusion.
Sure.
I don't know. I didn't finish the show.
Okay.
I got kind of tired of it.
At the rate I'm going, it'll take me 2 more years to finish the show. Because I don't watch TV otherwise. I don't watch TV or scroll social media or any of that. So I have no way to know what happened on that show. Maybe someone will leave a comment.
Yeah, tell us how it ended.
We could go, I guess we could look it up on.
I had a lot of friends who watched it, so I have an idea of the ending.
Gotcha. The lawyer character, the son who's the lawyer. So there's the whole thing where he's trying to run for attorney general.
Mm-hmm.
And then his dad turns on him. And I can't go up against my dad. I can't take on my dad. And the girl who was his campaign manager / girlfriend says, "You can, come on." She's like, "I believe in you. I'm here with you." And in the end, he's, "No, I can't do it." And she, "All right, fine, go be a wuss." And she basically walks out of his life. There's this foreshadowing part before that where he's coming out of this liquor store and there's this cowboy, this vagrant cowboy. I don't know if you'd call him vagrant. Kind of a day laborer cowboy, a cowboy for hire. And the cowboy for hire says to him as he's leaving the liquor store, he tries to give the guy 20. He's like, "It's a tough time of year. There's not a lot of work right now." And he tries to give him some money. And the guy's like, "Nah, I don't want your money." And as the lawyer's son is about to leave, the cowboy says to him, "Hey, do you know what a tie is?" And he's like, "What is it?" And the cowboy says to him, "It's the leash your master cut. He knows you ain't leaving. He knows you ain't leaving." You get the feeling when he says that, I had the feeling this is the moment when that son finds his backbone, when he finds his balls, and he's going to walk away from this whole thing and forge his own life. But instead, he just folds his card. He doesn't even play the hand he has. He doesn't even say, "Fuck it. Maybe my dad's coming at me, but I've raised some money. I've got some supporters. I'm going to make my run. And if it doesn't work out, it doesn't work out." No, he just folds his cards and says, "I'm just going to go back to the ranch and do what my dad wants." So it just proves that he himself was not able to get out of the ranch. He wasn't able to get out of the cult of the ranch.
There's more context to that comes later in the show. There's a lot more context to that. But you're right. He goes back and forth.
What do you think of that vacillation, that going back and forth?
That whole character is written as a coward. I think. You're not supposed to end up liking him either way, whether you agree with him ideologically or not. It makes sense that you wouldn't like him because people don't like it when you go back and forth on someone.
Well, he's extremely competent.
But extremely insecure at the same time.
Are all of us prone to that to some degree? To being both competent and at the same time insecure?
It's pretty hard to go back on what you know,
Okay.
where you were raised.
But we all know just by looking at how he manages money and how he acts in the courtroom, he's capable of making it probably anywhere.
Yeah, on his own anywhere. Yeah.
And probably being very successful on his own anywhere.
Right, but he needs that validation.
Validation, what do you mean?
He needs the validation from his father figure and his sister.
Okay. Why do you say father figure instead of father?
Oh, I don't think he's biologically his, if I recall correctly.
Really?
Yeah.
Huh. They didn't bring that up in the
Yeah,
show.
he's not his biological son. It comes out.
Really?
Yeah.
Huh. Okay. Well, I can tell you in the first or second episode, when the oldest son dies, it's almost like nobody flinches. You would think Kevin Costner's character takes the son's body back on a horse and buries it himself. And you would think he'd be like, fuck, you know?
Yeah.
But research shows that that basically a parent who loses a child is never the same. Like their life is permanently altered. But in this, and people who lose a sibling, it's the same. People who lose a sibling before they should, they feel that. But in this show, everybody's just, yeah, he died, life goes on.
That's just the show being a show. That's just lazy writing. That wasn't the writers thinking about the consequences of that, you know what I mean? They were using it as a tool to show some intensity and some scarcity and some necessity that the young one who was previously a SEAL come back.
The one who is previously a SEAL, he's the youngest.
I believe so.
Where I'm at is he's just come back after his wife basically said, I'm leaving. I'm getting the hell away from you.
His Native American wife?
Yes. He came back and they're trying to get him to run the ranch.
Mm-hmm.
He's not really running anything. It's more the dad and that lead ranch hand are still actually running everything.
The whole show is pretty chaotic, man. It never really makes... None of the decisions you would make are the decisions that are made.
Because I'll tell you, if I had that whole ranch, I couldn't imagine wanting the chaos in my life that they bring into
and the
this.
amount of war that they have to go to keep it.
I don't think in real life, it is not comprehensible to me that in real life you have to go to war like that to keep your ranch. Maybe you do at times, but it's just this deluge of crises.
And everyone wants a piece.
Right, and just nonstop violence and everything else. You see, if I had that kind of land and everything, I wouldn't need to go out and chase women or drink or anything. I think I'll go fishing today. I'll go ride my horse today.
The whole justification for them going to this kind of war, they show you it throughout the series multiple times, and it's usually centered around the sunrise or some sort of peaceful, cathartic activity that this land grants them.
Uh-huh.
But then the whole rest of the show is them going to war.
Right. So they never enjoy that peak. So they'd almost be better off selling the ranch and
No,
getting a place with a nice porch.
no rational person would keep it.
Especially given all that
Well,
it's worth.
Everyone in the show except the dad and the number 2 in line, they all want to sell it. Because they're like, this is shit. The daughter wants to sell it. The youngest is. It's creating contention between him and his wife, so he wants to get rid of it. But everyone is loyal to the dad.
Okay. Which, I don't know, I guess that's called a cult of personality. But then what's so appealing about his personality that would make so many people want to follow him? What's appealing about him is that he has the land, which nobody wants anyway.
Well, they want the money.
They want the money. Okay.
If he died, I guarantee they'd sell it. That's even what the daughter says is, until you're dead, we will own this ranch.
Okay. And then as soon as he's dead, they want to sell it just to get the money. But the other thing is, if you say, I'm going to hang in there to the end so I can get the money, then you have to look at it and say, is the money worth the time?
Well, it's not about the money. It's about being loyal to the dad.
Huh. Okay. Even though being loyal to the dad, what benefit does it bring them?
Almost nothing, dude. If I remember correctly, it ends with all of them dying.
Really?
Yeah, dude.
Okay. Something to look forward to.
Season 5, if you ever get there.
Okay, I'll pay attention. So, back to becoming who you are, to become who you are. Nietzsche almost makes it sound like the way it's phrased, that you become who you are just by ending the dissimulation, by quit. It would be like you don't show anything on Instagram that isn't actually you. All the stuff that's on people I know who create Instagrams, for the most part, they're showing things that really aren't actually them. They're just kind of a highlight reel of their life. Or they're a complete farce. It's a complete fakery. I saw a YouTube short where basically they were talking about this AI fitness influencer on Instagram. And she has 3 million followers. And she's completely AI. And I mean, the guy who created her, he went piece by piece and pixel by pixel to make her look as realistic as possible.
Okay.
But all the content is AI generated. It's not real. So social media is becoming this complete dissimulation where people are scrolling and looking at stuff on it, but they're looking at stuff that is contrived.
Okay. So when you talk about ending the dissimulation, what does that mean for decision making? Because if you sit there and if you go off of your first instinct, probably that could be the thing that is most you, is going off of your first thought. And you can make a similar argument that thinking it completely through is the most you.
Sure. Yeah.
And also you can use social media as an means to an end. You post on social media all the positive aspects of your life so that others and employers can look at that and say, this is an overwhelmingly positive person.
Because you
It's
project
a tool.
That's a good way to think about it. You're projecting this positive image. So at what point does it go from you project a positive image as a tool to help you to you have become an inauthentic person? At what point does that line get crossed?
Does it become disingenuous when it's not you doing those things? And when you believe the lies that you tell?
So it truly becomes disingenuous when you believe your own lies.
Yeah. Or you start to fool yourself into thinking you are this person.
So there's a part in Thus Spake Zarathustra, which was the work that marked the beginning of the second half of Nietzsche's philosophical career, where he writes this book that is supposed to be almost a systematic philosophy, but he does it largely through the language of metaphor. And in the first part of the first book, first chapter of the first book. So it begins with a prelude, and then you have the first book. You have book one. And the first chapter of that book, he says, I'm going to describe to you how the person becomes a camel, the camel becomes a lion, and the lion becomes a child. And he says that when someone first wants to know, when they first want to become a knowing person, when a spirit first wants to become a knowing spirit, it has to become a camel, where it learns how to bear burden. It learns how to follow the direction of the master and how to be just laden down with luggage, with the knowledge of the past. It's like you go to school and your teachers, your masters, they pile all this learning on you. But in the way he describes it, it's almost like religious learning. It's like in the process of learning knowledge, you're learning a way of life that then you're then expected to live up to. And then the dog drinks my water. So then the camel is, once it has all this pack put on it, it's sent out into the desert. You're given this education, and then you're sent out to figure out what to do with it, what to do with yourself. And in the desert, the camel becomes a lion. And it meets this, and the lion wants to do things its way. It wants to say, I learned these things, so now I'm not going to be told what to do. And there's a dragon out there that is covered with all these glittering scales. And on every scale is a rule, is a command. It says, thou shalt do this, thou shalt do that, thou shalt, thou shalt. And the lion, instead of listening to those thou shalts, the lion says, well, I will. And it doesn't mean I will do, it means I will, as in I will something into existence,
Yes.
or I have a will. And then, but then the lion has to become a child, has to also throw away its own will and say, and become forgetful and free in the world, and become an actual, instead of just a creator of its own direction each day, become a creator of its own values. Right? So I wonder if, I kind of think, because thus spake Zarathustra came after the gay science, if that was how Nietzsche answers that question, what is it to become who you are? It's to find your own will and then to find your own value set. But here's the problem I have with it. It makes it sound like that's an endpoint. But what I picture is that it's more of a cycle. Because maybe at that time in the 19th century, you could say, well, knowledge isn't growing at this incredible exponential pace to where you got to keep learning and learning and learning just to stay in place. Now we live at this time where there's just so much new knowledge coming in. And if you want to be ahead of things and you want to be growing in the world, you have to constantly become the camel, and you have to take on that burden of new knowledge. And then you have to go out and do something with it and allow it to change you as well. Like you have to become this thing that constantly finds new knowledge, integrates it, become something new yourself, and then find the next piece of knowledge.
You're skipping the child there.
Well, what I'm saying is the child is that integration, like that part where you say, I've taken in this new knowledge and I have become this changed person because of this new knowledge. But it's this constant endeavor of work almost to just learn and learn and learn.
It's intentional.
So anyway, that's how I've come to think of becoming who you are, is that you actually are in this constant journey of recreating yourself. What do you think? What do you think of that?
That's a solid way to view it.
I don't think it's what Nietzsche had in mind.
No. But I think if it kind of serves to help you, then it was worth him putting in a book. Growing and becoming more of who you are.
Uh-huh.
I don't think you ever, I think you're right in saying that you ever really achieve an endpoint. I don't think anyone really, until you are too old for it to matter, I don't think you reach an endpoint.
Well, I had a 81-year-old friend, and he said to me, the problem with life is just when you've got it figured out, it's over.
Yeah. And I don't think that necessarily is true, because the reason why he was able to figure it out was because there was nothing else going further didn't really matter at that point.
Well, okay, so his biggest struggle was that he at one point in his life had weighed 600 pounds.
Okay.
And he had lost a lot of weight, and he'd gotten the
skin removal?
Yeah, excess skin removal surgery. But he had serious edema in his legs.
Okay.
And he was fighting hard just to keep from losing his legs. Like, that was his goal. His main goal was, basically, he said to me, I want to die and still have my legs. I don't want to have to die an amputee.
And that's what he figured out?
I guess. Like, that was his biggest struggle.
That was his last hill to climb.
Right. It was to keep his legs.
That's a really tough end of life.
Dude, yeah.
Where you're fighting to keep your legs.
So, is that what end of life is in our society, though? You know? Is that just what it is for everybody? I mean, my grandma, she died at what, 84, 86, 84, somewhere in there. Mid-80s. And she told me the hardest part was losing her hearing. Because she couldn't talk to people anymore. Like, she could not communicate with anyone, it seemed, anymore.
For a lot of people with those kinds of disabilities, it's the losing it that sucks. It's not the start point, it's not the end point, it's the middle there.
Okay.
Where they begin to lose their
hearing. The process of losing it?
Losing their hearing, losing their sight.
Is it just because you can't get used to the loss? You can't just, if you lose a little bit, then you can get used to it. But if you just keep losing and losing, it's every day.
You're constantly reacting. Also, think about, drop it right now. How are you going to make friends if you can't hear? Immediately, right now. You stop being able to hear, you're going to have to learn how to make new friends. But on top of that, you're going to have to learn sign language or something.
Right.
A different way of communicating.
Right. And learn sign language when you have arthritis.
Right. I think what really is shitty for her is that she went through the middle point and died before reaching the end of it.
Okay.
Because I think on the other end of that, she would have found more peace.
That's entirely possible. Well, what it made me think about, I saw Mark Zuckerberg's whole weird presentation with the meta glasses, and they wound up not working. I was thinking, if you were a person who was losing your hearing, if you could have those glasses so that someone could talk to you and the words would appear in front of your eyes for you to read, that would be just such a game changer for your whole life. Have you heard about this Comet 3I Atlas?
No.
You haven't heard of the Comet 3I Atlas?
No.
Let's get started here.
Comet is an asteroid that's straight up made of ice, correct?
You know what? That's a good way to put it. Okay. So let me go to the beginning of this slideshow. All right. Here you go. All right. Let me hand that to you, and I'll flip the switcher so that everybody can see what that is. All right, so that is 3I Atlas. The I stands for interstellar because it's not originally part of our solar system. It's an interlocutor. So the first, and they're delineating these with a number and then the letter I. So, and then the last part is a name related to who discovered it. So first one was One Eye Oumuamua, probably can't pronounce it correctly, but it was discovered using the huge telescope up at the top of the mountain in Hawaii. It was discovered in Hawaii, basically. And it was a long cylindrical object that just came hurtling through the solar system. And then the second one was Two-Eye Borislav. And it was discovered when it was much further out. This one is Three-Eye Atlas, and Atlas stands for the Asteroid Terrestrial Alert System, basically to keep asteroids from impacting the Earth. And so this was discovered, and it's hurtling through our solar system, and it has this, the way you can know that it's not part of our solar system is that it doesn't have an elliptical orbit. It has a hyperbolic orbit, right? So with a hyperbolic orbit, with a hyperbola, you have an arc with a focus over here, but it never actually winds back around, right? Okay. So the focus...
It's passing by.
Right. The focus would be the sun, right? So the sun is altering its pathway. And if you go to the next slide, this will take a second to load up, but hit the play button. You have this video from NASA's page where it shows the expected path that it's following through the solar system. It's going 130,000 miles per hour. And for comparison, Earth travels at 67,000.
And then what is the speed of light?
It's 186,000 miles per second. So you have to multiply it by
3,600.
By an awful lot, by almost 4,000 to get to the speed of light. Go ahead and click to the next page. So what that is showing, so they directed Hubble at it to get an idea of how big it is. And Hubble said, based on the Hubble images, they said it's somewhere between 320 meters and 5.5 kilometers in diameter, which...
That's a range.
Yeah. But these images are actually from the JWST. And the JWST has these spectral telescopes and cameras on it, so it can look at things like the infrared spectrum and all that. So it's really good for figuring out the composition of things. It's also, with it being so good in the IR spectrum, in the infrared spectrum, it's really good at picking up very distant galaxies. So if a galaxy is redshifted, its X-rays, its gamma rays become infrared. And so with JWST, you can look 12 billion years, 13 billion years into the past to see these
oh my God,
distant galaxies, but actually you're looking far away, but you're actually looking into the past of the universe.
Because they're actually further than that.
Right. So on the upper left, I think that's labeled A. You tell me.
Yes.
Okay, so in the upper left, that's the dust cloud, and it's looking at the scattering of the dust cloud. And then I believe B and C B, C, and D are looking at H2O, CO2, and CO, and looking at how they are basically coming off of this. And as it goes toward the sun, and the thing is, if you remember from the path, it's never going to go, it's not going to go within Earth's orbit. It's going to get to about within 1.3, 1.4 astronomical units of the sun.
Okay.
So it's passing between the orbit of Earth and Mars. And actually, next week, it's going to be close enough to Mars to be able to be observed by the Mars orbiter. And that's actually going to be super close, and we're going to get even better photos, even better data. But what the JWST spectra found, and you could go to the next slide, these are the different spectra of the dust, the H2O, the carbon dioxide, and the carbon monoxide.
Oh, it even has heavy carbon dioxide.
Yeah, it even shows carbon-13 dioxide. And what this found, what the JWST data has found, and I think if you go to the next slide, you can see it. What you can see here is the ratio of carbon dioxide to water in that comet. Now, what you'll notice on there is all these other comets that are native to the solar system, they follow along that line. But this one, and there is one other, this one is way outside of it. And it's almost a 1-to-1 ratio of carbon dioxide to water.
It's more carbon dioxide than water.
So that's why the dust cloud coming off of it is so big, and it's ejecting so much material. In fact, what they found is that it's got to be cranking out about, I believe it's 150 kilograms per second. That is a lot of sweat coming off of that thing. But for it to be so high in carbon dioxide, what that means is that it had to have been formed beyond the carbon dioxide ice line in its original solar system. Do you understand what I mean by ice line?
No.
Picture a star, a protostar, an early star, a young star. It's cranking out all this heat. So if you're close enough to it, you're not going to form water ice, you're not going to form ice. And that's when you're within Mercury, Venus, Earth, Mars, you're within that range during the early solar system, because only rocky planets can form. But when you get outside of that, when you get out to Jupiter, you can have methane ice and water ice. So that's where you have these gas giants that form. They actually form originally as rocks of ice, as giant dirty ice cubes or muddy snowballs. And they form, and once they get big enough, they have enough pressure and enough heat, that pressure and absorb enough heat from the sun that they can liquefy and then turn into gas. Right? But by then there's already so much accumulated there that it doesn't just blow away, it stays in place. So you have this water line, you have this water ice line, because water freezes at a much higher temperature than carbon dioxide does. The other thing too is carbon dioxide gases off very easily when it's exposed to UV. So it had to have formed in a place where it was
UV.
What's that? Where it was shielded, where it was shadowed. Like in a very shadowy place around its original star, where light from that star wasn't getting to it. There wasn't enough radiation to bake off the CO2.
It'd be really cool if we could figure out which star it came from. But the options are just astronomical.
And given the plane it's moving in, because it's moving within the flat plane of the galaxy, within the pancake of the galaxy. So that means there's even more options. If it was whipping around outside of the plane, out of the galactic plane, then we would say, oh, well, it must have formed outside. And there's not a whole lot of stars outside of that pancake plane. So go to the next slide here, or the next image. Okay, so this is from a couple of professors. At first, when I read this paper, I thought this is kind of, when I read the original blog post that the second author on this, what's his name, Loeb? Abraham Loeb. I thought this guy is making some pretty wild conjectures, but it turns out he's a very accomplished astronomer and works for Harvard University and everything else. So he's really respected in his field. But what these three guys did, and this paper is only 3 pages long, if anybody wants to read it. What they did was they said, okay, the position of, what they said is, this thing is gassing out a lot of material. So, and that material is coming out at about, I believe it's 44 meters per second. So it's gassing out a lot of material that's coming out really fast. And so you can take that, and it's gassing out from the side that's facing the sun. And right now it's going toward the sun. So we should see an altered trajectory. We should be able to say, if it's gassing out that material, then you are going to have a change in momentum. That change in momentum, that gassing out creates an acceleration, an acceleration that's counter to the direction it's going in. And so if this thing doesn't have enough momentum to overcome that, then we should see a shift in its trajectory. And what they did was they took the position as measured by JWST, and they said, how heavy would this thing have to be? How much mass would it have to be overcoming that outgassing based on how the position isn't really altering very much?
Yeah.
And what they came up with was a minimum of 33 billion tons. So it's
3.3 times 10 to the 16th
yeah.
grams.
Yeah, 33 billion metric tons. So what that puts it up to is the very upper bound of what the Hubble data's radius said it could be. So what they did, they took that composition from the JWST, and they said, let's assume the whole thing is made up of this. Mm-hmm. That would put its density around 0.5 gram per cubic centimeter, which is about the same as Halley's Comet. Right? Okay. So given that density and what the mass would have to be, it actually puts it up at the upper edge of the diameter that Hubble said it could be. Now, in his blog, he conjectures that this may not be naturally occurring. This could be not just extrasolar, but extraterrestrial in origin. That feels like a leap to me. But maybe it's not such an invalid leap. I get where he's coming from. I don't think I have another slide on that. Yeah, that's the end of that one.
Okay.
What are your thoughts on 3i Atlas?
You said something intelligent could have made it?
That's what he implied. That's what he implied in his blog.
Gotcha.
That size makes it so anomalous. The other objects we've seen have been really small. Comets we see in our solar system, by comparison, are super small.
I wonder what process. I imagine that would have to be a byproduct of whatever their end goal was.
Why would you produce that?
I mean, we have, is it Challenger, is the probe that we sent out of the solar system? Voyager.
Voyager 1 and Voyager
right.
2.
Challenger is fucking...
Have you ever seen Star Trek the motion picture? Have you ever seen it?
No.
Okay, so it's the first Star Trek movie. And there's basically, they get sent out to save Earth from this giant space vehicle that calls itself V'ger.
Okay.
And it turns out that V'ger is actually the Voyager probe. It left the solar system and it went out and it accumulated all this matter and alien technology, and it became intelligent, and it was trying to come back home.
Oh.
Right.
That's a cool premise.
Yeah. The thing is, if you say somebody created this and they had a reason, well, that reason might already been fulfilled.
Yeah, I think more than likely, if it's just made of CO2 and water, how do we make CO2 and water? By burning things.
Right. Right.
I would guess that if it were extraterrestrial, it's got to be a byproduct of some other process.
It's a giant alien...
Trash ball?
Carbon sequestration. They said, we don't want to warm our planet. All the power plants and everything, we're going to capture the CO2 and just send it off as a comet into outer space.
I imagine it would have to be some intentional trying to do some extra, trying to get off of their planet. Right?
Okay.
Something that's already occurring off planet.
Some way for them to escape.
It's something them doing space travel.
Mm-hmm. Well, that would be quite a thing to put yourself in the middle of a ball of ice and carbon dioxide.
I'm saying that it's a byproduct of the manufacturing.
Ah, okay. We're both kind of the opinion that this thing could actually, if it is extraterrestrial in origin, it may just be a ball of extraterrestrial waste.
Yeah.
Okay. Are you ready to go to the next thing?
Yeah.
Okay.
That's a very cool thing, though.
Okay.
River deltas.
River deltas and soul stones on Mars. On the left, on the right, that's just a picture of a river surrounded by red Martian dirt. And what makes the Martian dirt red is that it's rust. It's iron oxide dust. So when we talk about the red planet, it's just coated with rust. I don't know what else to say. On the left, that is Vivianite.
And that's iron phosphate?
Iron phosphate octahydrate. So
Okay.
8 water molecules. And it's also called a soul stone because when the body decays, if you had a coffin that was made of iron or iron nails, iron bands, that would start to form on the iron parts. Yeah, if they would open up the coffin, even just after a few days, and they'd find rocks of Vivianite like that. But Vivianite, it's not uncommon for it to form, wastewater treatment facilities, because it's a product of decay of organic matter.
Yeah, anything containing iron.
Well, iron and phosphorus, which living things contain a lot of phosphorus. Adenosine triphosphate.
Yeah.
It's the energy currency of your body. So literally without phosphorus, you can't carry out.
Any biological function.
Next, we'll see what the next is. Syrtis Major is what this is called. On the right is the Syrtis Major quadrangle. And on the left, you see the whole planet there. And
Is this black spot here what you're talking about?
Syrtis Major. That whole black spot is lava from a shield volcano. And it is believed to have formed when the Noachian period on Mars started. Now, the Noachian period corresponds to the beginning of the late heavy bombardment period. This takes us on a wide tangent, but I'm all about it. If you look at Earth rocks, there are very, very few that have ever been found that are older than 3.8 billion years old.
But the planet itself is 4.5, correct?
4.6. Same with Mars, 4.6 billion years old. The Martian magnetic field, the core, the magnetic field is generated by the core. You have the very inner core is hot, and then the outer core is liquid iron and nickel. And because of the spinning of the planet, you get these convection currents because the inner core is superheating it, which sends it up, and then it hits the mantle, starts to cool, goes back down. You get these convection currents, and then the spinning of the planet makes these convection currents stable, like a gyroscope. You only need a little bit of magnetic field when you have something that's that big and spinning to produce a lot of electric current. And then you have this convection current that creates this initial electric current, and that builds on itself. And you have this self-creating magnetic field. This moving electrical current creates this vast magnetic field that covers the whole planet, protects the whole planet. On Mars, Mars is about, the diameter of Mars is a half or a quarter of Earth's. It's very small by comparison. It cooled off very quickly. Mars's mass is 15% the size of Earth, and its volume is 10% of the size of Earth, which is backward. Mars is more dense than Earth, which you would expect with it being further out in the solar system that it would be less dense, but it follows the opposite pattern. So it cooled very quickly relative to Earth. By 4.2 billion years ago, Mars had no more magnetic field. So back to Earth. You have this period of time from 3.8 billion years ago to today where we are able to find formations and rocks throughout the whole geological history. And we have the ability to radiologically date them to see how old they are. And we know that the solar system is about 4.6 billion years old because we've found meteorites and asteroids that are that old. And we know that through radiological dating. So there have been a few rocks found and a few small formations found that date back prior to that 3.8 billion years. But we're talking about very, very few.
Okay.
So the conjecture was, well, the surface of Earth, something must have been keeping it molten. But we didn't know what. Nobody had any idea what. When astronauts went to the moon, they brought back these samples. And they found a tremendous number of samples whose impact samples. And when you have an impact, you get an impact crater and you get a whole bunch of molten pieces that pop out of it. And you can use those molten pieces, you can radiologically date them. And they found that there were a huge number that had fallen between 4.1 and 3.8 billion years ago. So it's controversial to say that it happened. Nobody can say it isn't settled. It isn't 100% settled science that it happened that way. But when you talk about a lot of the formations on Mars, you have to look at it in the context of the late heavy bombardment period. So the Noachian period, the Noachian on Mars, corresponds to when that late heavy bombardment period would have started and ended. And you can't really see it on this image here, but if you were able to go a little bit south and so down into and it's believed that the asteroid that hit and created that Hellas crater, that impact actually set off the volcanism that created Syrtis Major, right? So in the upper corner of Syrtis Major is another formation. And if you go to the next slide. Okay, so you see on the lower left-hand side of this, you see Syrtis Major.
Okay.
And then on the right, you have the Isidis Basin, the Isidis Planitia, right? And you can see also marked on there is Jezero Crater.
Yeah.
And then above that is something called Nili Fosse. Yeah, so Nili Fosse. So what's believed to have happened is you have the impacts that created the Jezero Crater. Now I'm calling it Jezero. It's actually named after a city in Croatian. It's pronounced Jezero. But the NASA folks have been saying Jezero. So
Okay.
I'm just saying Jezero. You have all these little craters around Nili Fosse and the Jezero Crater, right? And what's believed is that impacts. And then there was this 200-kilometer wide asteroid that hit and created the Isidis Basin, right? And if you look at the picture of Nili Fosse, you can see that there's like 3 claw marks
Yes.
on it. And if you go to the next slide, that is Nili Fosse as it was photographed by the European Space Agency's Mars probe. And you can see the big trench. And that is actually, those trenches are believed to have been happened from that impact that created the Isidis Basin. Yeah, so go ahead to the next. So that's a timeline of Mars, a timeline of Martian geology. And you can see there's basically 3 significant periods, 3 dotted lines. You have the Noachian on the bottom and the Amazonian on the top. And what's the one in the middle?
Hesperian?
Okay, the Hesperian. So the Noachian is the most active. It's also, basically the Noachian and Hesperian were when you add significant amounts of liquid water that could form on the surface. Now, if you take those, if you go back a couple to the picture of the planet Mars, one more, you can see that there's polar caps.
Yeah.
And those are actually mostly water. They're about 90% water. And then they have a layer of CO2 ice on top.
Okay.
It's believed that underneath the South Pole there be a liquid lake. But it could also be super salty ice. But if there is that liquid lake underneath all that ice, we have one under our South Pole too, a liquid lake under all that ice. And there's an entire ecosystem down in that lake with chemosynthetic bacteria. There's all kinds of stuff in there. Go back to that timeline of Mars. When you get to the Amazonian period, that's what it is now. There are some impacts. Every now and then you get a warming period and some water comes down off of those poles, but otherwise you don't have a whole lot going on. And because Mars does not have a magnetic field, the atmosphere has been blown away. It's about 1% of the density of Earth's atmosphere. So even when you talk about wind and weathering, it doesn't weather at the rate that you have on Earth. Okay, next one. So this is the Jezero Crater. And the Jezero Crater matters because that's where Perseverance landed.
Okay.
This is where it was decided. People started pushing in 2015 for Perseverance to go to the Jezero Crater because there's so much interesting stuff there. Now, on the bottom left, you can see that there's delineated elevation, but it's negative. And that the reason it's negative is because that was determined by the Mars orbiting laser altimeter. It was a satellite that was put up there. It was only up there for a few years in the late 90s and early 2000s. But what it did was it mapped the surface of Mars.
Okay.
And what it found is this crater, you have one side of it where you have this drainage, this fan that drains into it. And then on the other side, you have, it goes up, but it doesn't go up as high. So you have this other side where it would drain back out, right? And if you look at that picture on the right, you should be able to see, I believe you can see, where it's delineated, there should be some purple lines.
Yeah, there's a couple rivers going in and then one out.
Right, yeah. Obviously, though, when all this was done, it was empty. There's no water there now.
Yeah.
Right. Yeah, go to the next. I can't remember what I have next. Okay, so Perseverance landed, and for the first 3 months, it didn't go anywhere. And the video of Perseverance landing is on YouTube, and it has 17.5 million views. Do you think we'll get 17.5?
This is the video, I feel it.
So it didn't go anywhere. What they did, though, was they took photos of everything around it. Now, this is after it started moving, and where they decided to go in late 2021 and 2022 was toward the western fan, right? There's a northern drainage fan and a western drainage fan, and the western drainage fan just looks better formed, right? So they pointed in that direction, started tracking in that direction, and you can see that butte. That's the Kodiak Butte in the Jezero Crater, and it's about 500 meters wide.
Okay.
And I believe 50 or 16 meters tall. So
not all that tall.
Not super tall, no. But you look at it and you can see that there's layers of sediment, right? And if you look at the picture on the lower right, you can, that's not the Kodiak. That's part of the escarpment, that's part of the crater edge.
Okay.
But you can see that you have this buildup of sediment, and some of it has broken off and slid down the side,
Okay.
right? So that's very, very solid evidence that you didn't just, you can see the sediment is different. The layers are different.
Yes.
So you didn't just have one occurrence of having water in there. There had to have been multiple periods of water being there for a significant amount of time, flooding and water staying there, and flooding and water staying there. And this all would have been probably during that Noachian period.
Okay.
It's impossible to actually date these radiologically because they'd have to come back to Earth to actually find, to really get at the uranium atoms and use that to date it.
They just don't have those kinds of labs on these probes.
Exactly. Go to the next. So more pictures of the Kodiak. I love the Kodiak. On the left there, you can see the Kodiak and you can see the fan. You can see the delta behind it. I mean, how majestic is that?
It's beautiful.
How bad do you wish you could climb it?
It'd be fun.
It looks like you could just hike right up that thing.
If you said Mars has 15% the mass,
Right.
you'd have a pretty easy time.
There's no oxygen. Hold your breath.
Assuming you have a suit.
I mean, I guess, I don't know. Temperature on Mars gets what, down to negative 100?
Look, man,
At
we're
night,
dreaming here.
I think
right?
during the day it's warmer than that, though. It's probably only like negative 20, negative 30.
We can do that.
I mean, we're in Minnesota. It gets that cold. We've been through it.
Thick
Yeah.
leather jacket, snow pants.
So on that one, does it show the elevations on that, on the Kodiak?
Okay.
So you can see how tall it is. And those elevations are in meters. But yeah, they really laid out in this paper the different sedimentary layers and how they're formed on there. And it just makes you realize that the red planet, even though we think of it as a dead place, there was a lot going on there.
Yeah.
Yeah, go to the next. Yeah, so that was basically their drawing of what it would have looked like back when it was full of water, and based on the imagery they had gotten from that Kodiak. Right now that was one of the first papers that came out of this, so it was pretty early.
Okay, so it was never really all that deep.
No, no, it wasn't like Crater Lake, right? But yeah, you're talking about, yeah, you're talking about 40, 50 meters of water. We can go back to that first.
Well, it has it right here.
How deep?
It has the edge as being 2395, and then the water being 2490.
2395 and 2490. Okay,
Yeah.
so 95 meters.
But
95 meters. That's about 310 feet.
it has the Kodiak as, oh, okay, but it's on the edge. Okay.
Right. Right. Now you can, it also should have does that one have a star on it?
Yep.
It says OEB.
Mm-hmm.
That's Octavia E. Butler. I think I have her on the next slide. Maybe I do. Yeah, Octavia E. Butler. That's who the landing site was named after. She was a science fiction writer and obviously an African-American woman. And she started writing science fiction all the way back in the 60s. And I would say a lot of her work isn't so much science fiction as speculative fiction, because she doesn't worry so much about finding mechanisms for things. Of course, in science fiction, you watch Star Trek and you're, oh, what kind of cake is it? It's a cellular peptide cake. They just kind of come up with some jargon that a cellular peptide cake would be a protein cake. But she didn't worry about coming up with those goofy kind of explanations. She just kind of wrote stories. The only story of hers I've read is Kindred. And actually, I've read the graphic novel adaptation. But maybe I should pick up a copy of her actual work and read her actual words. I just thought it was a good, interesting book when I read it, but she's actually one of the most acclaimed science fiction writers of all time, and there are a lot of people who are just huge fans of her trilogies.
Okay.
We'll go to the next. That is Perseverance, and you can see it has all these different contraptions on it. So you have the mast cam. That's what takes all those panoramic photos, and it can zoom in and everything. There's another one near the back called RimFax. It might be on the back. RimFax, what it does is, as the rover moves along, it shoots radar into the ground, like ground penetrating radar.
Okay.
And it uses that to determine the density of the ground beneath it, right? And it can actually determine different layers of ground. The Sherlock camera on the front, it's actually multiple instruments in one. It has a black and white camera. It also has wide angle camera that's for seeing the topography of small samples, but that's called Watson. And it also has a laser that does Raman spectroscopy. Now there's a couple different types of spectroscopy, so I want to just explain this real quick. When you shine light through a crystal, that light scatters. And
Okay.
you remember from physics, like you do the thing where you bounce the balls off each other and you get elastic and inelastic
Yeah.
collisions. So some of that scattering is elastic and some of it's inelastic. So with the Rayleigh scattering, you're not losing energy or momentum. And with the Raman scattering, you are. So what that tells me is some of the light coming in is being absorbed by the electrons on the bonds, by the electrons of what's in there, and then being spit back out. And so it's going to come out at a different wavelength than it went in. And you can use that to see what these rocks are made of. The science has gotten so sophisticated that they can identify entire minerals based on that spectroscopy. So that's two things we're going to talk about, is RimFax and Sherlock. That's the Sherlock camera again. And that is the spectroscopy that came out of the latest paper talking about potential life on Mars. But for this, I just wanted to show that's kind of what the data looks like coming out of that Sherlock camera. Go to the next. So we're not going to talk about life on Mars yet. We're going to talk about a little bit more about the layers within this crater. So in 2022, this was the path that Perseverance took, and you can see it went up one part of the fan and then it came down. They went to the western fan and went up one part of the fan and then came back down and then went up another part. And that whole time it's going along and it's acquiring data through RimFax about the floor of the crater. Let's go to the next. And this is what it found, is that the density of the crater floor is greater than the density of whatever was on top of it. So you can see that boundary marker. As it went toward the edge of the crater, you get this thinner and thinner sediment layer. And that sediment layer is about 0.16 grams per cc lighter than the crater floor, which tells you that it's sediment. Because you can assume that the composition, the actual chemical composition, wouldn't be that different, right? But the way it falls and lays down and aggregates gives a little more space between those rocks. You follow me? The
Yeah.
crater floor, everything is sandwiched together super tight. But with the sediment on top, it wouldn't be as tight, right?
Okay.
And this also tells us how thick that layer of sediment is, right? And given how thick it is, on Earth, you would expect that kind of sediment to settle out of a still lake at a rate of about 2 centimeters per year.
Okay.
And given how thick it is, and that 2 centimeters per year is on the high end. So
Okay.
that lake had to have been there for at least 500 years, unless you're talking about a completely different process, which there's no reason to think it would have been different.
Right.
Yeah, go to the next. So the bottom line with that is you had these substantial periods of time where water was filling the Jezero Crater, right? And then after it was done exploring that western fan, it went up, and I believe this is called Nervada Vallis?
Yeah.
Nervada Vallis. That actually means Valley of Heavenly Water. It may or may not mean that, but Nervada means heavenly water. And Vallis means valley. So Heavenly Water Valley. It went up and it looked specifically at rock samples at all these different sites. And you can see there's Valhalla Glade and Apollo Temple, and there's Masonic Temple. There's a bunch of different outcroppings that are named on this map here.
Okay.
Right? So go to the next. And what it found was these two, it found lots and lots of minerals. But the two that stood out were these two. You have Greigite on the right, where you can see it's iron sulfide. And then...
On the right?
Yeah, on the right.
You have it as iron oxide.
Well, I'll have to correct that. I copied the wrong thing. It's iron sulfide.
Okay.
Sorry, folks. I'll correct that. Instead of an O, it should be an S. And then we have the other mineral we talked about. I can't even remember the name. The soulstone.
Yes.
So if you go to the next slide. So the Greigite was found at Apollo Temple. And if you look at the bottom of those charts, you should have our other one.
What are you saying?
The name, if you look at the bottom right.
Oh, Vivianite.
Vivianite. So you have the Greigite and the Vivianite. Vivianite was found at several different sites on there. And the thing is, Greigite and Vivianite rarely, they can both be created by biological processes.
Okay.
Right? They can also be created by abiotic processes, not involving light. In both cases, you need a lot of organic matter. And because the organic matter, you need that as a source of phosphate. And with the Greigite, you're basically starting with iron sulfate. Now, all these volcanoes on Mars, all this volcanism that occurred both as a result of its own plate tectonics and as a result of all these asteroids hitting, those volcanoes were cranking out lots and lots of sulfates. So that's a source of sulfur. But that sulfur is tied to oxygen. So you have to peel that oxygen out somehow. Now, with biological life, with bacteria doing chemosynthesis, they can actually use that as a way to basically they can use it as food. They can get some energy from it. If you're doing it they can do it at a relatively cool temperature.
Okay.
If you're doing it and they can do it quickly, so bacteria can do it quickly at a cool temperature. But if you're doing it without bacteria, if you're doing it without the assistance of life, you need the organic matter to absorb the oxygen. You also need it to be hot. You also need to have lots of iron. And it needs to occur over a very, very long period of time. You're spending all this time baking out that oxygen. So it has to be this anoxic environment, like no oxygen. It's the same with the Vivianite. It has to be anoxic. The problem is if you have them forming together, iron sulfide is much less soluble than iron phosphate. So that iron is going to attach preferentially to the sulfide and fall out of solution very quickly.
Okay.
So if you don't have a biological process that's mediating and regulating these, it's almost impossible to get them to occur at the same time.
Simultaneously.
So go to the next. That bump, you see the G bump? The
Yes.
G band. So at the bottom there, you have the baseline, and then you have these 3 different bands above it at different sites. That G band represents the presence of organic matter. And you can see that where the bump is the biggest was at where?
Apollo Temple.
Where the Greigite was found. So go to the next. So this kind of puts us in what I'm calling a logical pincer. So you can say, you have this argument where you could say the most likely origin, if we were talking about Earth, if we found this stuff all together, if we were talking about planet Earth where we know life exists, we would say this was almost certainly created biologically. Even if there's nothing living there now, that's probably what happened. Here's the alternative. We say, well, it didn't necessarily happen biologically, so assume it didn't happen biologically. Then what you have to have is this long period of time where that water was present. And not just like 500 years, like you can say, is how quickly that sediment could have all fallen out, right? You have to say tens of thousands to millions of years. And it had to stay hot that whole time on this planet that's basically cold, that doesn't have an atmosphere. And then you're going to have to say, if it could have stayed wet and anoxic, and you had all this organic material, right, at this spot for tens of thousands or millions of years, why would you not have life evolve and arise on it? So that's the pincer you're in, is you're either saying there was biological life that made it happen, and that's why it was able to happen within a time frame that corresponds with the sedimentary data.
Right.
Or you're saying this happened over this long period of time, but somehow, even though within that same period of time life sparked into existence on Earth, it didn't happen on Mars. And you have to explain that. So in my opinion, this puts you out into that 2 to 3 sigma area, maybe even 4 sigma, where you're saying there's a 1 in 1,000 or 1 in 10,000 chance that this was not
life. Okay.
So whenever I see this stuff about, oh, there could be life, I'm always skeptical. And part of it is because what does it really matter to me? Life was on Mars, now it's not. I'm interested in it whether there was life or not. So when they talk about, oh, we might find life, I know that they're appealing to a certain group of people. That doesn't include me. But in this case, I find the evidence pretty freaking convincing.
Yeah, that there has to be life.
That there has to have been
life.
Right. And if there was life on Mars then...
It probably is now.
Right, especially if you have a liquid lake or even a frozen lake under those ice caps.
The thing about life is that it finds a way.
Look at water bears.
Right, right.
I mean, they put those, in the vacuum of space for weeks? And you come back, put water on them, and they're right back to doing their thing?
Right.
And look at, this is kind of a little bit morbid, but when you talk about things, C. diff, Clostridium difficile, basically antibiotic resistant, very often deadly colon infection.
Right.
It forms spores that you basically have to bleach them to kill them. And if there's bacteria on Mars, there's no reason to think that they couldn't just hunker down and survive in those polar caps.
Right. Because even here on Earth, we have things that exist well outside the realm of light.
Right.
Deep on the ocean floors.
Right. And so one thing that Perseverance does is it takes core samples of these rocks with the idea that eventually we'll be able to send something there that could pick them up and bring them back, right? And hopefully that'll happen before
you and I are dead.
Right. But there's no reason you couldn't put a probe, say, up by those polar caps and take cores of those polar caps. Within these rock samples, we might very well find the fossilized shapes of bacteria
Right. There was actually a meteorite that landed in, I believe, Antarctica, where they found fossils that looked like bacteria fossils.
They could be bacterial fossils.
Yes.
Really?
They looked like it. Just with this, there does exist an explanation where it's not life,
Right.
but it's also very lifelike.
Huh. Okay. It's just there's not enough of any other material
Right.
to figure out what it really is.
Mhm.
Yeah. Huh. So I think if you could get core samples from the poles, you wouldn't just be relegated to finding fossilized evidence of life. I think
You might find some.
you'd find actual bacteria. Because I mean, think how many bacteria there are. You take one breath, like how many billions are you sucking in?
Right.
Yeah. So if there was bacteria on one part of that planet, it would have just,
Yeah, been everywhere.
yeah, they would have flooded the whole thing. Yeah. So those were the things I had to talk about this week. Do you got anything else you
what
want to
about
cover?
your future implications? Yeah?
That was actually that was actually something I started all the way back a couple years ago, or about a year and a half ago, and I just never got to the point of making a video for the Sexy Universe about it. So that actually would have been the close of that slide, the close of that deck. But I made that deck before this last discovery came out, like pretty much nearly pinning down life on Mars.
Gotcha.
So anyway, I'll put that slide up on the website, or that slide deck, that whole slide deck with the references and all the pages, like up on the website when I post this episode. So if anybody wants to see it, they can go there. I'll put a link in the description too.
Okay.
Cool.
Kind of speaking on the persistence of life, we can talk about the Ochre Star.
What's the Ochre Star?
The Ochre Star is a sea star that I was seeing down in Morro Bay in California. And, well, it was Montaña de Oro, which is just south of Morro Bay.
Beautiful spot.
And I was wondering if I could safely, if it was safe to gently handle these sea stars.
Uh-huh.
And before I did that, I looked them up, made sure it was okay. And what I found is that it's legal to pick them up and handle them, but unless you're a marine biologist, everyone basically says, please don't.
Okay.
And what I found out was that part of the issue is that you may introduce to these sea stars bacteria or other pathogens from your hand that ruin the microbiome that's on top of their skin.
Huh.
So a lot like our gut biome, they have a microbiome.
Well, you have a microbiome in your skin too.
Well, on the outside of their skin, they have a microbiome. And a big issue with that microbiome can be any bacteria that exists on top of it. If it's overly aerobic, it'll consume all the oxygen that the sea star otherwise would have.
Huh.
And it'll suffocate the sea star from outside of its skin.
So the sea star's microbiome won't outcompete like the intruders.
Right, the regular kind. Because currently now, the water along the California-Washington, ranging all the way up from Alaska to the bottom tip of Baja California,
Okay.
the water temperature is increasing, just
Okay.
like everywhere else on Earth. So these essentially pathogenic or otherwise harmful bacteria are starting to proliferate because the environment is making them more competitive at the moment.
Ah, I see. Okay.
And since about 2015, along the western coast of Pac Rim, we've seen a massive dying of sea stars. caused by bacteria existing on the outside of their skin.
And are you talking about all species of sea star or this specific species?
There's a lot that don't get affected by it, and there's a lot that do get affected by it. And one in particular, the sunflower sea star, it is the second largest sea star on planet Earth. And right now it's nearly extinct because what researchers believe is the same bacteria that the ochre star is suffering from. But since 2015, the ochre star had this massive dying off, but then there seems to have been a small genetic mutation that makes that particular bacteria much less competitive on their skin.
Okay.
So the ochre star has actually had a massive burst.
Kind of got a lucky break.
Yeah. Yeah, and they're not this, there's a specific word, there's a specific term for this massive sea star dying.
Okay.
They're not quite at the numbers that they were,
Okay.
but they're doing much better. They're on the up and up.
Okay.
But the sunflower sea star, in biology, you have what's called a producer, primary consumer, secondary consumer, tertiary, and it just goes up from there, right? The ochre sea star is a secondary consumer.
Okay.
So something eats the algae, sea star eats that.
Okay.
Well, the sunflower sea star is a secondary and tertiary consumer.
Okay.
And
So a lot higher up the chain.
yes,
Okay.
those apex predators are much more sensitive to environmental changes on average. Things that everything else eventually adapt to, a lot of times those apex predators, they never do.
Okay.
And the sunflower sea star,
Is it just because their food sources become so depleted that they can't get enough, like, as a species to continue to survive?
and they exist in fewer numbers as well.
Oh, so there's fewer to start with. Okay.
And there's less genetic
Diversity.
diversity between them.
Okay.
So,
They got fewer switches they can pull to try to survive it anyway.
yeah.
Okay.
So, basically, the sunflower sea stars are almost gone.
Likely, does the pathway look like they might make it, or does it look like they're kind of doomed?
So, along the coast, there are a couple of aquariums that have initiated captive breeding with them.
Okay.
The thing is, for these particular problems, funding is so bad.
Yeah.
Resources dedicated to it are so poor
There's so few. Yeah.
that usually by the time these final steps are taken, it's usually too late because there's a learning curve there.
Right.
Not everything feels like getting it on inside of a tank.
Right.
'Cause you can't even get eels. There's no captive breeding for eels ever that's been successful.
Really?
Right.
Huh. You know, when you talk about conservation efforts like that, when you talk about all the shipping that goes on along that Pacific Ocean, right? If you took those containers and you just said, we're going to have a contribution, a tax, or however you want to, whatever you want to call it, however you want to get it, of even just a tenth of a cent for every container, you would have enough money to fund conservation efforts and cleanup efforts all across that entire coast. And not just the American part of it. I mean, all the way throughout that whole Pacific Rim. It would not take, it would be such a small amount that it wouldn't even be noticeable. It wouldn't even really show up in the products you purchase every day. But it would make a radical difference for cleaning up the environment and conserving species and getting rid of the plastics that are just pervading the Pacific Ocean right now. Even just a minor amount of money would make a huge impact.
Right. Well, we don't.
Well, hopefully we will.
But
It's worth fighting for. It's worth
Right.
talking about. Yeah.
and the resources, they're so low that these aquariums and research groups within them, they could not figure out whether the sea star wasting disease, that's what it's called, was this particular plague of it right now. They couldn't figure out whether it was viral or bacterial for a long time, for over the half of the span that it's been going on.
Uh-huh.
It wasn't until an aquarium almost lost all of their sea stars that they were able to try enough things to figure it out.
Okay. To keep them alive.
Yeah,
Now, have they had success with breeding them?
I don't know.
Okay.
Basically, what they had to do is all their sea stars were dying to this sea star wasting disease.
Mm-hmm.
They went from 300 specimens down to 90% of them died. It was 10 to 30 were remaining. And what they found out is what they did is they dropped a massive antibiotic into the tank and then gave the sea stars probiotics on top of their skin to prevent them from dying.
That sounds to me like a last-ditch, desperate attempt.
Yeah, and it worked.
Thank God. It was a Hail Mary.
They almost lost everything, and then they basically wiped everything out. And then, so off of that, there was two contenders, right, for what's causing it,
Uh-huh.
for what was causing this current plague of sea star wasting disease, and that eliminated the viral factor.
Wow. Okay.
And this isn't the first time that sea star wasting disease has occurred, proliferated along the coast there. But this is the longest, the most endemic.
Okay.
It,
If it's being driven by a warming climate, it's probably not going to stop.
that's the prevailing theory, is that
Okay.
it's caused by global warming.
Huh. Okay.
And it's not every sea star currently that's dying. And the ochre sea star in particular, there was a study to see how carbonic the water could become, right? How much carbonic acid can exist within the water. And we're likely to die before the ochre sea star goes extinct.
Okay.
They estimated that it will survive for at least a century, but that was before this bacterial factor
Right.
came in. But now, thankfully, they've adapted and survived it.
But that's one of the big problems with climate change is that you get all these unexpected knock-on effects that have these enormous consequences for
Right.
ecosystems and species within them.
Right. Yeah, it's almost certainly over, in my opinion, for the sunflower sea star. It's extremely grave.
I'm hoping
Eh,
these conservation efforts work.
Yes. And they are totally worthwhile endeavors. I'm not saying it's not worth it to try.
Right. And even if you fail, hopefully you learn enough that you can succeed the next time.
Right. I'm just saying the way the facts are laid out in front of us, it may be a done deal. They're critically endangered right now. The only thing worse is only existing inside of captivity
Okay.
before extinction.
Okay. Man, that is a dark way to end our episode, but, you know.
Well, all that is to say is taking the ochre sea star that did survive this is that life, almost no matter what, prevails. It almost
Right.
always survives in some form. And we talk about the big trash island. It's currently shrinking. The prevailing theory there is that some bacteria has developed to consume the plastic.
Oh. There are several bacterial enzymes that have evolved to consume different forms of plastic,
There,
particularly polyethylene terephthalate, PTFE. Yeah.
there is maggots who have had their gut biomes modified with a genetically modified bacteria that can break down polystyrene.
No way.
So styrofoam.
Right. Reproduce? Do
Yes.
They keep it? Okay. All right. We need a lot more of those up at the landfill.
And I've had my tattoo artist, she was worried about that. She was, if something can consume plastic, what does that mean for us? And I think in the same way that...
It's nothing but positive.
Well,
Straight up.
Also, think about books. There are plenty of things that can consume your books, but if you take care of them, keep them dry, you know, keep them in a dark spot, they don't get consumed randomly.
Right. Right.
You just clean up your plastics.
In my opinion, there are some things that are just worth fighting for. There's some things that are just worth trying. When you talk about the conservation efforts to try to preserve the sea star.
The sunflower sea star.
Even if it didn't work, with the ochre sea star, even if it didn't work,
Right.
it's still worth trying. And it just might work.
Right.
So whatever you're talking about, trying to do the right thing, trying to make the world a little bit better.
Whether you're picking up trash on trails that you walk through.
Right. It's so worth it just to make that small effort. And it may just make a big difference. It may be the thing that makes a big difference for an entire species.
Right. And you can think about it this way. Like when you adopt a stray animal, right? You can have someone who's negative about that, and it's just like, you didn't really make a big change in the world. To that particular animal, you made a world of difference.
You change the whole world.
Right. And it's the same thing for keeping our world biodiverse.
I totally agree. And on that note, I believe the ideal life is a nonstop process of learning and growing. Thanks for learning and growing with us. Stay on your game, and we'll see you next time on Everybody's Podcast.
Alrighty.
Good work, dude. We kicked ass.